Hello everyone. In this video lecture, I will explain about an important concept of linear algebra, that is eigenvalue and eigenvector. I hope in previous video you understand the concept of row echelon form and rank of matrix and column space. So here, while computing eigenvalues and eigenvector, row echelon form will play a crucial role. So if you have not seen the previous lecture, please see that. So let us define first eigenvalue. So if A be a matrix, square matrix, then a constant lambda is called eigenvalue of matrix A if determinant of A minus lambda I equal to 0. So to find eigenvalues, you have to solve this determinant and equate to 0. This is called characteristic equation of matrix A. So now for simplicity, I have written here how to find or how to write this determinant for 3 cross 3 matrix. So you have to subtract the lambda from diagonal elements of 3 cross 3 matrix and equate to 0. So on expanding this, it will give you an equation that we call characteristic equation. And after finding the roots of that characteristic equation, I will get eigenvalues of matrix A. So if matrix is 2 cross 2, I will get 2 eigenvalues. If matrix is 3 cross 3, I will get 3 eigenvectors. They can be repeated, they can be distinct. So let us see the direct way of writing characteristic equation. So for 2 cross 2 matrix, one can easily write the characteristic equation lambda square minus trace of matrix A. Trace means the sum of diagonal elements A plus D and minus data of A equal to 0. For 3 cross 3 matrix, we can simply write this as lambda cube minus trace of matrix A into lambda square plus sum of principal minors into lambda minus data of A equal to 0. So I think this is the easier way than solving the determinant here A minus lambda I equal to 0. So you can use this way or you can use directly this formula to write down characteristic equation of matrix A. After that, you can solve this cubic equation for 3 cross 3 matrix to get 3 eigenvalues of matrix. Next, let us see. I will explain how to find these sum of principal minors and the trace of matrix in the examples. Before that, let us look at eigenvectors. So what is eigenvector? A non-zero. Remember the word non-zero vector x is called an eigenvector for the eigenvalue lambda of matrix A if ax minus lambda or ax equal to lambda x. That means I want to find out the vector which transform into a constant multiple of itself by matrix A. So this means I can write now here ax minus lambda x equal to 0. 0 is the 0 matrix here. And more simplified, I can write a minus lambda I x equal to 0. So our task is to find this x here. And this is now a system of homogeneous equation in matrix form. So if I write this matrix as B here, so this Bx equal to 0, which is a system of homogeneous equation, and we already have understanding of how to get solution of homogeneous system. So as lambda is an eigenvalue of matrix A, this system have always non-trivial solution. That means data of A minus lambda I equal to 0, or equivalently I can say rank of A minus lambda I should be less than n. Now let us see few examples how to find eigenvalue and eigenvector. So first I have taken one example here. Find the eigenvalue and eigenvectors of the matrix and matrix is given as a square matrix 3 cross 3. So this is a particular type of matrix here, which is upper triangular. So we already know that. You can note down that eigenvalues of upper triangular matrix UTM or lower triangular matrix LTM or diagonal matrix are diagonal elements. So this fact will save your time while computing eigenvalues. Although if required, you can write the characteristic equation and then you can solve it. So here I can write directly what is lambda 1 and lambda 2, lambda 3, and this implies eigenvalues are diagonal elements. That means 3, 2, and 5. So I can write this lambda 1 for simplicity and for lambda 2, and third one is lambda 3. You can write in any order, order will not matter here. So I got the eigenvalues. Now let's find eigenvector for lambda 1 equal to 3. So eigenvector for lambda 1 equal to 3. So this I can write as case 1. So you remember how to find eigenvector of matrix here? So we have to solve the system A minus lambda 1 I into x1 equal to 0 matrix. Here x1 you can write x1, x2, x3, or you can write as x, y, z. 0 is the 0 matrix here. So I have to write a system A minus lambda 1 x equal to 0. So A minus lambda 1 is 3 here. So 3i into x1 equal to 0. So if I subtract here this 3i from A, I have matrix equivalent to this 0, because 3 minus 3 will be 0 here, and then 1, 4, and second I have, let us see what is the matrix, 0 here, okay, 0, and then minus 1 will be here, and 6 is there, next 0, 0, and 5 minus 3 is 2. x1 equal to 0. So now here a very crucial role is there, how you can solve this system. So we already know that we have to change the matrix into equivalent form. Then we can choose the free variable and then we can write the vector x. So now see here in the first row what is leading element is 1 here. In the second row leading element is just below the leading element of previous, which will not make this an echelon form or row echelon form of matrix. So I have to make this element 0 here. So I will do an operation R2 in change R2 plus R1. So this will give you a matrix here 0, 1, 4, 0, 0, 6, and last row is 0, 0, 2, and x1 equal to 0. Again, this is the leading element, and in second row, this one is leading element. In third row, this I need to make 0 to ensure that matrix is in REF. So I will apply again one operation, R3 change to R3 minus 1 by 3 R2. Okay, so we can write here now 0, 1, 4, 0, 0, 6, and 0, 0, 0. And now we have checked that this is now in echelon form, as 0 row is at bottom and leading element in a row is at right side to the leading element in previous row. Now this x1 I can write as xyz, and right side vector 0 vector I can write 0 0 0. So you can see this is a system where matrix coefficient matrix is in REF, row echelon form. So we can use back substitution. Before that we have to choose what is free variable here. So how to choose free variable? Free variable can be chosen by looking at the leading element place. So if I check out the x place, y place and z place, so which column has leading elements? So y has leading element, x column has leading element, sorry, z column has a leading element, x column don't have a leading element. So free variable will be x and let us is as a k. Okay, so let x is equal to k. Now, by using back substitution, we can find out y and z. We can, by R2, what I got? 6 times z is equal to 0. Actually, this is 0 times x plus 0 times y plus 6 times z equal to 0. And this implies z equal to 0. Now, similarly, by row 1, what I got? 0 times x plus 1 times y, so y plus 4z is equal to 0, which will give you, because z is 0 here, so y also 0. So, by using back substitution, you get the vector x, and this implies vector x1 is x, y, z, and this means you have now this x, z is 0, y is 0, and x is k, where k belongs to integers. That means positive. K cannot be 0. So I can write simply k cannot be 0. Because if k is 0, then x1 will be 0 vector. We are not finding a 0 vector. Eigenvector must be always non-zero vector. So simply many times we are taking for k equal to 1, we have x1 is equal to 1, 0, 0. You can take any value of k, but more simplicity we are taking k equal to 1. Now this is the eigenvector for lambda 1 equal to first eigenvalue 3. So for lambda 2 equal to 2, let us find this eigenvector again here. So what I need to solve? I need to solve a system A minus lambda 2i into x2, I will say equal to 0, 0 matrix. And here x2 is again x, y, z. So let us write the matrix here. What will be the matrix? So I can easily write this will be A minus 2 I equal to 0. So this will reduce to a matrix which is 1 here, 1 here, and 4, then 0, and then here I have 2 minus 2 is 0, and then 6 here, then 0, 0, 5 minus 2 is 3 here, and x2 is equal to 0 matrix. Now this is more simple case, it seems, because there is leading element in this first row, second row has leading element at this place, and third row leading element is just below it, so I have to make this a 0. So we can apply suitable operation. That means I can write R3 is changed now, R3 minus 1 by 2 R2. So this matrix will change to row echelon form, that is 1, 1 now, 4, 0, 0, 6, and then I have 0, 0, and this 3 minus 3 will be 0. X2 is equal to 0. So this is clearly in echelon form because 0 row is at bottom and leading element in the rows is at right side to the leading element in previous row. So by using this, we can now write here xyz in place of x2. So I can write x, y, z as it is in REF form. And the 0 matrix can be 0 vector now. And this means we have to write first what is free variable. So x place as leading element, z place as leading element. Where is no leading element? Y place. So y will be here a free variable. Let's y equal to k. Then by using back substitution by R2, what will get? 6 times z, 0 times x plus 0 times y plus 0 times plus 6 times z equal to 0, and this means z equal to 0. Now by using first row, what I will get here? X plus y plus 4z equal to 0. So now put the value of y and z here in this. So I have x plus k and plus 0 equal to 0. This means x equal to minus k. So vector x is minus k. Now we can write the eigenvector as x2 is equal to x, y, z. And this means we can write now minus k, k and 0, z is 0. And which is, this implies for k equal to 1, x2 will be minus 1, 1 and 1. No, 0. K equal to 1. So this is your second eigenvector. Now similarly, you can find out third eigenvector. So k's third will be for lambda 3 equal to 5. So now in this one, we just solve again a minus, it is repetitive process. So lambda 3 I x3 is equal to 0 vector, where x3 is again x, y, z as I am taking from beginning. So now write down the matrix for a minus lambda 3. So a minus 5i x3 is equal to 0. So it's very simple to write down the matrix. It changed now. So here I have minus 2, 1, 4, 0, and then minus 3 here, and 6. And then I have third row is 0, 0, and 5 minus 5 is 0. So again, now I have to seek the pivots or leading elements. So first row I have this minus 2 as leading element. Second row minus 3 as leading element. And this is already in row echelon form as third row is 0 and leading element in any row is at right side to the leading element in previous row. So I can write now the vector here x, y, z and right side 0, 0, 0. Now it is easy to simplify. Now guess what is the free variable here. So here free variable will be, I hope you understand, it is z because z the third column has no leading element. So let z equal to k. Now use back substitution. We can simply write now here from second row, that is R2, we can write minus 3 times y plus 6z equal to 0. And this means minus 3y plus 6k equal to 0, which gives you y equal to 2 times k. Now use the first row to get x. So I can write by using the first row here. We can write minus 2 times x plus y plus 4z equal to 0. So this is by R1. Now just simplify to get x value. So minus 2 times x plus y value is 2k and plus 4k, because z is k equal to 0, and this implies minus 2x plus 6k is equal to 0, and this will give you x equal to 3k. So I got now the vector x3 also here, and this implies x3 vector is x, y, z, which is z here, then not z, it is k, k here, 2k here, and 3k here. And this means x3 is now 3, 2, 1 for k is equal to 1. So we got eigenvalues and eigenvector for a given matrix which is upper triangular. Similarly, we can find the eigenvalue and eigenvector for any kind of matrix. Let us take one more example here. So example number 2 I will take here. So find eigenvalues and eigenvector of matrix, which is again 3 cross 3. So A is given as 1, minus 1, and 4, 3, 2, minus 1, and 2, 1, minus 1. So this time it is a very common matrix, not upper triangular, not lower triangular like in previous example. So we have to first find out the characteristic equation. So to find out characteristic equation, first you can go two ways, either A minus lambda I equal to 0, or you can write directly the formula. So better is you can use direct way. So what is the direct way formula? Lambda cube minus trace of matrix A into lambda square plus sum of principal minors, that is A11 plus A22 plus A33, and into lambda minus determinant of matrix A equal to 0. So let us compute every component required here. So what is the trace of matrix? Trace means sum of diagonal elements. So it is 1 plus 2 minus 1, and that means it is 2 here. And similarly, you can find what is determinant of A. So here, determinant of matrix is minus 6. And now I can find sum of principal minors. So A11 plus A22 plus A33 will be, so principal minor means minor of first element. So this one is the first element. So I have to delete the rows and column passing through this element to get the minor. So first row and first column deleted. So I have date of this 2 minus 1, 1 minus 1 plus Second, for this one, I have to delete this element. I have to delete second row and second column and then compute the data of rest. So I have now 1, 4 and 2 minus 1 and plus third, that is the last element here. I have to delete third column and third row and compute the data of remaining components. So I have 1 minus 1 here and then I have 3 and 2. So I hope you understand how to compute sum of principal minor, which is major component here. Compute this sum of principal minors. Now this I can simplify. So this means I have here minus 2 and plus 1. So I have minus 1 plus here this minus 1 and then minus 8. So I have minus 9 here and plus this 2 and plus 3, that is 5. So in total I have here uh, minus 10 plus 5, so minus 5. So this third entry is now I have minus 5, and this means I can now write, this implies characteristic equation is lambda cube minus this 2 times lambda square and plus the sum of principal minor, that is minus 5. So I have minus here. So minus 5 times lambda and then data of this is minus 6 here. So again this will become minus 6. So minus minus become plus here, equal to 0. Now we got the characteristic equation here. For this you have to find out the roots, and roots will be the eigen values of the matrix. So what is the initial point to find out the first root, because it's 3 cross 3. So I have to easily check one of the root for this particular equation. So if you remember initial guess, what could be the initial guess? It is the, if for standard one, ax cube plus bx square plus cx plus d equal to 0, initial guess is equal to plus minus factors of d divided by factors of a. So here it is 1 here. So you have to ultimately find out the factors of last term, that is 6, to get eigen vectors or the factors of this. And this means, let us check for lambda equal to this 6, 1 is here. So these factors are 3 and 2 and 1. And this means lambda 1 equal to 1. I have already checked this. This is an eigenvalue of the matrix of this characteristic equation. Now remaining two vectors you can find by dividing this characteristic equation by a factor lambda minus 1. So remaining two eigenvector values are lambda 2 equal to minus 2 and lambda 3 equal to 3. Now one important point I want to mention here, how to check whether these eigenvalues are correct or not, or in general how to check the eigenvalues are correct or not correct. So you have to check out first. There are 2 points to remember or to make in mind. First point is, so note down here, to check correctness of eigenvalue. First one is very important property, that lambda 1 plus lambda 2 plus lambda 3, that is sum of eigenvalues, must be trace of matrix A, and product of eigenvalues lambda 1 into lambda 2 into lambda 3, this must be determinant of matrix A. So these two conditions are you have to verify before moving further for finding eigenvector. So let us go ahead and you can check conditions here. So lambda 1 is 1 minus 2 and 3. So what is the sum of this eigenvalues? So 3 minus 2 is 1 and 1 plus 1 is 2. So trace is 2 and you can easily check here trace is 2. Now what is the product of these eigenvalues? 3 into 2 minus 2, that is minus 6 into 1. So minus 6 is the det of matrix. So this means these eigenvalues are correct. Now you can find out eigenvectors for these eigenvalues. Let us find the eigenvalue for first eigenvector for first eigenvalue lambda 1 equal to 1. So I'll follow same procedure. So eigenvector for case 1 for lambda 1 equal to 1. I need to solve here a minus lambda 1 I x1 is equal to 0 vector. Here x1 again I am taking x, y, z. And this means a minus I x1 equal to 0. So as the given matrix is a general matrix, there are no zero entries. So let us subtract 1 from diagonals of original matrix. And let us see what I got here. So this is 1 minus 1. I have 0 here. So this will change to 0 minus 1 and 4. Second row is 3, 1 minus 1. Third row is 2, 1 minus 2. x1 equal to 0. Now we have to be very clear that this matrix should be changed into row echelon form so that I can easily write x, y, z. So let us first make the leading element in first row as first element. So I need to interchange the rows. So let's change R2 and R1 first. Then it gives you 3, 1 minus 1 and 0 minus 1, 4, and third row is unchanged. So 2, 1 minus 2, x1 equal to 0. Next, as 3 is now the leading element here, and the second I have to make this 0. So first I will operate now here. You can think about like we can multiply this third row by 3. So 3 are 3 and minus 2 are 1. And this means you can write simply R3 is changed to R3 minus 2 by 3 R1. So apply here R3 minus 2 by 3 R1. So this will give you a new matrix 3, 1, minus 1, 0, minus 1, and 4. And here it is 0, and then here 1 by 3, and here minus 4 by 3. And x1 equal to 0. Now I can easily see this is the leading element in the first row, second one, this one. And in third row, I have this to make 0 by using second row. So you can guess the operation. I can apply simply R3 is now changed to this R3 plus 1 by 3 R2. So this will leads you 3, 1, minus 1, 0, minus 1, and 4, then 0, 0, and this will also become 0. So here is REF form of matrix A minus lambda 1I equal to 0. Now you can easily find out which one is free variable here. So first place has leading element, second position have also leading element, third there is no leading element, and this implies what is the free variable. So free variable here is Z. So let Z equal to K. Then by using the second row, what I got? 0 times x minus y plus 4z equal to 0. And this means y is equal to 4 times k because z is k. So 4 times k. This is y. Now using again first row, this means this row I got here 3 times x plus y minus z equal to 0, and this will give you 3 times x plus 4 times k minus k equal to 0. So what it leads? This means it has 3 times x plus 3 times k equal to 0. It means x equal to minus k. And this means what is the vector here now? X1 is x, y, z, and this is equal to minus k, 4k, and k. For simplicity, you can write minus 1, 4, 1 for k equal to 1. So this is the first eigenvector corresponding to first eigenvalue. Remaining eigenvalues for eigenvalues 2 and 3, you can find out eigenvector as a practice. And I'm writing answer for these two. So case 2, for lambda 2 equal to minus 2, what is x2? This is as is 1, 1, 1, 1. And for case 3, lambda 3 equal to 3, eigenvector is 1, 2, 1. These are for k equal to 1.